So I'm jumping right back in with what I was doing before, this combat thing, except I've had a day to think about it. And I also left myself some notes. I think that right about now's the right spot in something like this to scrap what I've got and write it again. And I know I'm already doing a major rewrite of the whole architecture, but I'm not going to start from the ground up this time. The first rewrite went back to base because it was, the first iteration through. This is a little bit of a second phase. Like the wave of progress has moved forward a little bit. I haven't actually reclaimed feature parity with the first one yet, but I'm pushing into new territory instead of reclaiming old things because those old things are very easy to reconstruct whenever I'm ready to grab them. But this new stuff was stuff I wasn't sure how to do yet, so I'm really pushing on the boundary of what I don't know how to do. And I think I've got enough of a picture now that, and it's getting complex enough that a rewrite moment has come. But it's going to have to be the kind of rewrite that doesn't scrap everything. So part of the question now is going to be to figure out what I do scrap. Now here are the notes I left for myself um, about how all this works. And the I'm gonna go through these and talk about them. But the other thing that I need to do is to kind of think about how I want to turn this into a picture. We were doing Milton over here, and this is kind of right, but I just am gonna I'm gonna kind of just say like, here was just brainstorming from yesterday. That's day one thinking. Now I want to do it again. It's just like those were good pictures, but let's not get stuck in the past here. Let's just do some day two pictures from how everything feels in the mind today. Certain things might simplify, new important details might pop out. We'll see what happens. To 3N, 4N in the chat, I just started streaming. You might have just happened to. I mean, I wasn't even streaming 12 hours ago, so probably there's some kind of mistake. But no, I just got started. Okay, so I'm going to read my thoughts here. So a couple of things I'm thinking of there being things like move kind. So there's also going to be like tiles. So like, the tile for attack is a little bit different. Um, um, right. So this here is an example of how like all of this is kind of going together. It's all bleeding together into one architecture. So I already have tile scripts. And looking at this and typing that out, I am thinking about if I want to do a new iteration on how I write tile scripts. One of the things that sucks about tile scripts is that they have these headers and that the way you attach multiple handlers to the tiles is through these ifs. it could be something that could be more like a scripted string. So it could be like how might I do this? Um, right, and then I could just go like, it's not my favorite way to do things because complex multi-lined inputs like these in strings are kind of too much. Part of the point of this scripting system is to use C to get the job done. So what if instead the tile script literally just had the outer structure? So it could be like, I suppose it could be like this. This would be when decremented, and it wouldn't actually come with this. It would just be when for the heart, when this is decremented. I guess we wouldn't need to say this. We would just do this. Right. So I think we could end up rewriting tile scripts this way. It means we have to bind multiple parts of the tile together by this name. And then we have to just play nice and not go modifying other tiles from far away. But if we do things this way, then I no longer need to use an if here. I can figure out a full data structure for describing the handlers on a tile script. And I can do that right from the declarations of these clauses. And so that will become that, and then these can be, the header can just be the tile script itself, right? So there's that. Now, the other piece of this idea is that there's this change from using tiles for this to just having a move kind. And this would be more like so that would get rid of these. And the move kind would just be an enum, kind of like well, I don't think the states are enums right now. You like kind of like the events are, and then and then there's this thing about rules and these states here. So when you are in one of these states, or rather, the machine for running this simulation is now going to have a property of having a current list of parties that are playing the game, right? Or like a list of players. And those players, at least in the current structure of the game, also correspond one-to-one with a party. And in the case of a chase game, they score one-to-one with a speed score for that party. So in this pseudocode, I kind of just pretended they're all there at the same exact level. But ultimately what I'm thinking is each one, there's a list of current players. And each player is in a particular state. And maybe it's more like there's a set of parties, and each party is in a state, and then one player might actually control multiple parties simultaneously in the future. But that would just be so that it can have control over things in multiple different states. But the rules of the game are defined in terms of what a party can do, what can be done through these parties, given what states these parties are in. And so the machine has a list of parties, not a list of players. I think that's the right thought process. I think it has a list of parties, and those parties, each party is in one of these states. Okay. Now, not all possible combinations are equally legal or like reachable, right? Not all imaginable combinations, not all of the combinations of states here can happen, because we enter in with each of them being at the beginning of the round. So they both get this round, right? And this might be like combat round or something like that if you wanted. And so when two parties meet in a combat round, each one decides to fight or flee. And so a decision gets made here, and then we go to a state based on those decisions. So here, the decision to fight or flee is a decision of which directly correlates with going to one of the states. So I created a list and said pick one where the two options were states. Now this means that behind this we need two different systems. One is a human player interface and another is a bot brain interface. We're not actually building human player interfaces yet, but this is where the logic for communicating with those systems would go. And of course, when we actually code this in C, I'm going to want some way to issue both of the potentials and then wait for them to resolve. So we're going to probably end up in coroutine land for the next iteration. I think that it's time to make the jump to coroutine land to make some of this make more sense. Well, except that for the simulation to go fast, the coroutine shouldn't actually be handing off to another stack, right? For this to go fast, what needs to happen is the bot brains need to be built in to the main thread too. Um, so that I think the right logic here is when you get here, if the player is a computer brain, then it will just run the computer brain in line. But if it's a human, then the coroutine architecture would come into play. And maybe I can defer the coroutine architecture and still be okay for a bit. Once these were a coroutine, okay, so I guess the idea is once it's, well, while it's simulating, it could be on a coroutine that just never gets interrupted. It just becomes a main thread basically until the end of the simulation. But if there were a player plugged into the simulation, then the coroutine would constantly pause to deal with the player and get information from them, to trade information with the player, right? So then there are these other rules that also deal with these. So we could get 4 combinations out of this because there are 2 players, each choosing a fight or flee option. And then there are 4 possible outcomes. But there are symmetries. So fight, flee is actually 2 of the outcomes, right? The rule matching system is going to be... it's gonna assume a symmetric rule, essentially, right? Both parties came in to this game equally, and so each step of the way through, whichever everyone picks fight and whichever one picks flee, if it's a fight flee pair, then the rules play out the same either way. So we modify the fight state into a chase state in that case, right? So this is like saying, remember I have a list of parties. Here I have party 0 is in combat round state and party 1 is in combat round state. I have each player pick a new state, and then we go to the state that is M0, M1. Now, if that's a flee fight state, we will notice that it actually matches this and swap the order of the parties and then run it through this. Then we'll change the state of party in slot 0 from fight to chase and keep this state as flee. That'll give us a new state to match, which is chase flee right here. And then this rule will run. If both players picked fight, then this rule would run. I don't have here in the notes, but there's also a rule for if both parties picked flee, then just gotta get the pseudocode right, you know? Okay, we pick moves from each party. Then we run all those moves and some KO checks and exit. Okay, so the way that would look as a C script would have to be something like now the hard part here, this is a part I don't actually have a full idea for yet. Hey, Paging Turner. Yeah, I got on a little earlier today. How are you doing? The hard part here is, like, you might imagine I can just go combat round, but this means that all rule scripts will be pairs. But this only makes sense because this happens to be a rule for a game with 2 parties. But there might also be sub games with a single round. You know, there might be like travel round. There might be arriving at a city or something, right? There's a number of things that might be happening. So the question is, how can this work? It could be some kind of variadic argument. I probably wouldn't be able to get away with dropping the macro here, though. I don't think. Right? Because I don't know any way to use a variadic macro and apply something to each element of the list, right? I can only move the whole list around, I think. And that might be something that's actually doable. I just have never found a consistent way to do it. But you could imagine if I just bite the bullet and put those in the list, then this could be like rule script, combat round, right? And under the hood, rule script is taking in ... and it would look kind of like the scripts we have for everything else. Unfortunately, I'm not sure how we're going to get a unique symbol for it. We might also need, like, just to throw in a name. It's annoying. I'm not sure, but I'll just punt on that issue for now. I don't know if we actually need to use an ID or gathered array for this. We just need a hook, rule script, and then you would register rule script, this kind of sucks. the registration system doesn't actually support this. So I would need to dig into that and improve upon it. But it seems like it would be doable after that. It would be something like right? Like that should be doable. I think we could do that and stick a 0 there at the end to cap the list. Or we could do it the other way, where you put the number of states down first, and so you'd be like, okay, this is a rule for 2. This is travel. It's a rule for 1. Having to put these symbols in is maybe the worst part. Is there any way I could drop that and still make it work? That's the next question then. I would need some way that I could say I was going to confidently generate a symbol name for every single one of these. Well, there's the counter. Okay. I wasn't really asking about C++. Not that it doesn't work. Okay. Now the issue is, can I get it to use the same value twice back to back? Or better yet, 3 times. I think I can't. So what I do is I drop symbol from the outer API. Then we'll put the counter down here. So this will be like and then we glue RPG hook func counter on the outside one. So this now doesn't need a symbol name, but it generates a symbol name with the counter and passes it down to the one that actually sets us up. Then the rule, okay, we still need to be able to register something with a var args list there. But what should happen is I should be able to say, oh, I guess I also need to put the num in right here. That's what's confusing me. Okay. So I should be able to say like, okay, so I've got a rule for fight flee. I don't need a name for it, but I want to then go this is where I do want to start introducing a concept of player. So I'm thinking something like Player pick one now. Do I want to just pass in actual literal states? The problem with that is, at least so far, I haven't given them any additional information about themselves. There'd be no way to construct an interface for a human from the list, and there's no logic by which to construct like the brain either. Like there's no, I guess the only thing that's sort of doable is I could just say it's pretty easy to construct a brain in combat round whose job is a brain whose behavior is when that brain sees a party in combat round always chooses fight, and then if you want a different rule you override it and you choose flee once in a while, so you can create the thief brain that does steal something and run away or whatever. And then for the player AI, the one that runs the player in the simulation, it would become more sophisticated. It would have to be able to analyze the situation and decide if its plan is how it's going to fight, or if it wants to run, and what the pros and cons are. That'd get fairly complex. But either way, you would phrase it in terms of uses of these symbols. But to show it to a human, you would need to know some display information, like Ugh. Okay. Before we go any farther, I want to stop and think about this language of move sets. It's going to work out nicely, I think, if I can throw it onto a Scratch arena somehow. Yeah, it looks right now like it's just saying, "Oh, manage this on the context," but that feels like the wrong place for the memory to go. It's actually all local memory, which means this entire system of creating these things and the splits will be fairly cheap to in terms of memory, but they'll still need a new move set. So yeah, I think we want like a Scratch for all of that. So anytime we're turning a move set, we'll pass it an arena. Hey Maria, welcome back. And then arena and temp Scratch. So that I think is the way to do it. It's a little funky to have stuff with this context thing is really just here for the purpose of gathering here. Possible party moves is actually a split that can operate without the context. Player pick subset limit. So I think this one will need the context because it might go to the coroutine or it might go to a brain, which needs to be able to inspect states. So this one does, in fact, contain the context along with everything else. Scratch Arena context moves, player moves. Okay, Scratch Arena. But we can join these without having to join those without having to well, we could rearrange things a little bit here. We could have RPG move set party moves 2 and just save each of the party moves there. And then this can be join an array of sets into one set, and then split. Then we do all these things to run the moves. And that's it. Okay. I feel like this would just be easier if I ran it like this, right? Like flee goes first, and then we just do a for loop. So if the fleers go slower than the chasers, then we go to let's see, fight. Then you have to fight. You got chase down. If the fleers are faster than the chasers, then you disengage. And if you're a tie, then you just go back to a regular combat round where you can keep on trying to run, keep on trying to chase, see what happens next time. Or you can turn around and fight or whatever. All right, I'm gonna take a quick break. I've sketched out most of the code from the brainstorm I did over here, and it feels really, really doable. It is a major change from the current structure of states and moves and stuff, but I think that's necessary. I'm gonna take a 5-minute break, maybe a 5 to 10-minute break here. And when I get back, we will just pick this up and maybe draw some pictures or something. All right. See ya shortly. Alrighty. Let's just finish writing out all the examples from this system. This will also involve going combat speed clear, but there will be a difference, which is that now we're going to gather moves from both parties, which are both in the flee state, so they'll both think they're running away from the other party. And their moves go off at the same time in that case. Okay. In addition to what we've got so far, I think I want to add in KO check. Now there is an unresolved question here about how combat-specific concepts are going to be filtering through the context. For now, I'm building them in again, which isn't the right thing, but I'm not quite sure what I do want. One child count. And now if count 0 is equal to 0 and count 1 is equal to 0, Okay. Maria asks, what does RPG GoTo do? It's a good question. I haven't actually implemented yet. This is all inside of an if0 block because I'm just sketching out ideas here. But the idea I'm shooting for is that um, in the core machine that's going to run this, the main state of the machine that controls, sort of like how a normal program has an instruction pointer or a current line of code. At this level of structure that I'm playing with, not there's still lines of code obviously, but at the level of structure that the GoTo is related to, I am thinking of a state machine that has the following structure. There's an array of one or more parties that each one has some state, right? So if there are two parties, then there are two state values, one for each party. And then there are rules that say what to do for certain combinations of states. So, for instance, when the system's in combat round, that means we have two parties. They're both at the beginning of a combat round. And you can see then this flows to a pair of states that's determined by some player choices. They might flow to the fight or the flee state, and so on and so on. So the go-tos here, and here, and so on are saying which state to go to next. And they do that by saying how to reset the states of each party given their current order. So this puts this is an array of states, two values. We started with two parties, each in the combat round state, and now we have a state for each one. So we're going to say, okay, we've got it could be fight, it could be flee, or it could be a fight, flee combo of some kind. And then each combination gets a signal or a rule. And so, for instance, if we get a fight and flee here, well, we're saying the rules are symmetric. So if we get a flee fight, that'll actually also match with this one. Order doesn't matter. So that's a part of what makes this a little more interesting than just having an enum with a state code that I'm self-managing, is that it's going to do a little bit of a pattern matching thing. Specifically, it's going to ignore the order. It's going to make them commutative so that the rules are symmetric for any given game. And so the rule here says what happens if we have one party in the fight state and one party in the flee state, and it says, oh, actually there's no game logic here. Instead, convert this state into a chase state. That's all this one does, right? But each of them has to end with a go-to because that tells it where to go next in the state space, right? Now, all of this has a fixed set of parties. This is all a game for a party for two. This whole thing is a two-party game so far. But what's going to happen is somewhere along the way, I need to build in a system that does a transition to a one-player party, because I also have some one-player party games that I want to include and interleave a transition in and out. So there'll need to be some sort of rule for go-to here that is more than just changing the states of the current parties, but more like transferring some of the parties that are currently in play into a new array, so changing the array and the states all at once. Haven't got to that part yet, but that's going to be a piece of it too, probably. Okay. So I think I've written out everything from the concept. I want to switch now to trying to draw this. So the main things I want to draw are the new pictures I have in my head for this architecture. And if I'm honest, some of it is just not a picture in my head yet. I'm not sure what I want it to look like in my head. And so maybe a part of this is taking a first crack at figuring out how to visualize the machine that I'm going to construct. But like I was saying, the machine has a state. So the machine architecture will go right here. at any given point, there'll be a thing called the current. Let's call this. Just I don't want to use the word state, but maybe more like the state array or something like that. So a state array will be a list of party and state codes all right. I'll write down a little axiom here. Actually, let's give it a different name. Let's call it axiom / invariant rule is that I'm going to get a little bit more technical today. Is n an element of the natural numbers? And okay, I'm going to do this again. I feel like I screwed it up in terms of spacing out the text, and I chose the wrong notation system today. I don't want to do a loose diagram. I'm getting technical. So let's do this. A state array is n, a counting number, and a map to pairs of party and state codes. So just because this is a Allen notation that I don't think anyone else in the world uses, let me just leave some notes here. This notation means the set 1, 2, ... through n. So it's a set of the numbers from 1 to n inclusive. And so to say that, or if we want to, we could do this in programmer speak today because we're getting technical. In this case, it's going to be 0. Actually, let me do it fully the way I normally annotate this. Put a little 0 there for this. 1 ... n minus 1. That's cool. Let's back that up. I did terrible with the layout here. I'm gonna do white, this green, this, and then I'm gonna zoom in. This notation stands for the set 0, 1, ... n minus 1. Okay. So there's my state array. And other things which are built in here, we have state. So state comes from this. A state is Buzztronic asks, I once asked myself whether text editors rewrite the whole file if only a small portion of it changed. Do you know if there are text editors that can detect, for example, if only one block has changed and only rewrite that block? Maybe there are, but I'm not sure how much you would bother. That's much easier for something like a hex editor, because the issue is that wherever you modify the text file, unless you do only insert operations, you modify every byte in the file from there forward. So there might be text editors that don't bother modifying the whole file. They just modify the part from the first change forward. That'd be a fairly easy thing to do. And I think that that'd be about as far as I'd expect any editor to go. Just because of how I don't expect that you would get very, like, you wouldn't very often, it'd be pretty rare to find a situation where you could avoid changing later blocks. All right, let's see. So there's a set of states, and then there's a set of rules. So a rule is a rule is an array of state codes, or a list of state codes, you know, and a procedure pointer, right? So this is n n0 to state but not to party, right? The party part is a parameter. The state part is sort of the parameter matching rule. So now the question is, okay, yeah, so that's all good, but there are some axioms or rules that have to be followed here. So we'll say, and there's an invariant that S is the, if S is the state or is a state array, programmer notation though, S is a state array, then for all oops, let's call this comma P is a, okay, ij s dot n for all I and j in, let's do this like this, okay, for all I, j in s dot n, I not equal to j implies s dot p I dot party does not equal s dot pj dot party, right? And then we have a thing like a rule set, which is, oh, and the rule comes also with well, let's call this a rule. I'm going to rename this. Okay, I think this is going to clean things up if I do it a little differently than what I got right here. We're narrowing in on this bit by bit. So a rule pattern is the kind of thing that you get when you have a count, let's call it n, which is a natural number, and p, which is a map, indexing or indexed by n to some states. And we say that okay, we're going to add in a vocab term here. We're going to say given S and T are both rule patterns, we say that S matches means that for all states Q the count of Q the number, let's say the number okay. Now a rule set maps let's say it maps a rule pattern So we'll factor out matches, right? We'll factor out all the matches, so that a pattern, because this forms a sort of equivalence relationship, right? So we can then factor the original set down to this refined version where two patterns that match are considered equal. And now I can state what I really mean by a rule set, which is that it is a mapping from rule patterns to hooks. And of course, we have a map. Let me leave a note here. Now, by the fact that this is a map, there cannot be two copies of a rule pattern, and by the fact that it's a complete map, I'm saying whatever rule pattern you've got, there's some solution. This will be achieved by having a default, so maybe if I want to be a little more technical, it's actually maybe a hook, and then there will be a default hook, and now the machine update rule is going to look like this. So the machine state altogether is going to be a machine state is a state array and a rule set. Well, I don't feel like I need to write that. It doesn't do much. What I mean to get to, though, is that an update rule or we could call it tick is it's a map from a rule set and a state array to a new state array. The rule sets don't get changed. This is like the code. This is like the instruction pointer. Okay, that will work for now. That's going to have to evolve because I do think the rule set will actually start changing. The rule set will be expanded with a sort of stack system or something, and on that stack there may be local modifications to the handlers so that, for instance, exiting out of a combat scenario can mean different things depending on what context it was placed within in the first place. The part where the combat system refers to itself is a closed loop. It is not impacted by the definitions from outside, but where it gives an exit state or a dead state, it doesn't. That module isn't saying what should happen next, and so I think then the next stage of fallback before just going to a default is to look for temporary rules that have been equipped to the context that give meaning to defeating the enemy or getting defeated by this enemy or whatever. Okay. Okay, I think this is about right. So what's left after figuring all that out is figuring out the pattern of rewrite that I want to go with. How am I going to make the code transition happen? I'll start by looking over here at chase. I kind of feel like I should just drop the current chase sequence because I haven't been touching it, and I'm kind of redeveloping it in this new system. Maria asks if the tiles in the system refers to like a map with terrain, and the answer is no. It's not situated in a space like that. The tiles are more like if you ever played like a lot of RPGs, you would play as a character and you get like moves, and then a lot of times in the not in a Final Fantasy game. In a Final Fantasy game, you're going through like the menu, you know what I mean, like the up and down, and Pokemon's like that too. You go through a menu, but then in a different branch of the RPG genre, you have a character and you get like squares, and each square has a little picture on it and a name, and it does something. And usually in these kinds of games, it's more about cooldowns or like charges or something like that you have for these moves. And usually you have like them on a hotkey or something. That's why they're squares. They're kind of mashed up with the keyboard. And that's what I meant by tile, is that kind of like a thing on a character that does stuff, and they're programmable. They can, in my system, they can stand for abilities, they can stand for stats, they can stand for counters, just like generic counters, they can stand for status effects, and so on and so on. So the tiles kind of equip the thing that they are on with information and rules for updating their state. Now, That does remind me, there is an issue with my current tile system, which is that I kind of set it up embedded within a hierarchy where there's like a party, and a party has multiple characters, and each character has multiple tiles. But it turns out I kind of want to be able to equip tiles all the way up and down the hierarchy. I want to be able to have tiles for characters, tiles for parties, and even tiles for the environment or for the whole context. And so that's going to need changing, and I don't think it makes sense to be accessing tiles through the same entity systems as everything else, because that could definitely be put through a optimization pass, since basically what the tiles do is each one carries a counter and potentially some hooks, so that if you have at least one of these tiles on your character or on your board, then those hooks get hooked into the game. Like they might say, when something happens to this character, this tile responds by doing something automatically, or by giving the player an option. But I also want to have at this point like tiles that say things maybe like things about like the quest state you might be in as a party, like if you have to a certain number of days to complete something, that might be the structure of that quest might be tracked as state in your party through the tile system. Or if you're in a location where there's a modifier to the basic rules because of the environment, then that could be equipped as a tile that just hooks in and changes something, or modifies the rules of the game a little bit by hooking it. And so I want to be able to get to that point, so it's not entirely there. But the reason I stopped pushing forward on the tile scripting is because tile scripting was going really well, and I want to figure out how to do the opposite, which is instead of scripts that hook in to the system, I want to figure out how to script out more micro scenarios like combat. So I that's what we're focused on. But once I've got both pieces living together properly, then I think the next big step is to really overhaul the tile scripting or the tile board data structure situation, so that it can be used to hook more than just the character events. Yeah, tiles mean more like tiles in a board game. If there was going to be a map, the tiles would still be more like what you have on a private board or what you have on a public board, separate from the spatial dimension of the game. So if you equip the tile, if you equip this game with a grid, and you wanted to use the tiles to script out 2D movement patterns, like you could probably script chess this way, right? You'd have a board, an 8x8 board, and each piece would have a tile or a couple tiles on it that represent possible moves they can do. And then each turn, all those tiles check if it's possible to implement those moves and what options there might be, and present that set of moves then to a player, right? And part of this is all about like turn-based gameplay. There's always in this system a setup of a certain amount of information is delivered to a player, a certain space of moves as possible, and an interface has to be presented either to a bot or to a human, which are different problems. But in one direction or the other, an interface has to be provided with all the information about what can be done, and give some kind of actuators that let the agent choose which one to do, and then feed those choices back into the simulation, right? And so the built-in assumptions of the game, of the simulation engine, are that there are programmable entities which are programmed in a variety of, like a miscellaneous variety of ways through the tiles, and there are one or more game loops of states that have hookable moments. And so turns happen where a complete amount of, like, the state of the game delivers a certain amount of information and a move space to a player. Players deliver move choices back into the engine. Another way you can think about the tiles, though, is they're kind of like variables on a scripting language, right? An entity has this tile set on it, and each tile gets declared ahead of time, right? So there might be like some pre-declared fact that the tile exists, like speed or whatever. And then somewhere in the code, you go RPG tile inc, and you go like, here's my character. I want to increment the tile called speed by 1 or whatever, right? So in this way, this is acting as the entity that's like the table on the scripting language, the object of the scripting language. This is the variable name, essentially. It works out to being an ID at runtime. And then this is the increment amount. And then this is going to reach into like a data structure. It might be a dictionary or some kind of more optimized, indexing or like memory efficient space, like a bit field. If we know, for instance, some tiles, speed isn't a good example, but we can know statically, for instance, that it's a good example. Sleep has a fixed max of 1 and gets discarded at 0. This special combination means that it's either there or it's not there, right? If it's at 0, which is the smallest value it can be at, then it's not there at all. If it's 1, then it's there. So this is the way you set up a bit, and so each tile that has this particular stacking rule would probably just get filtered off into a bit field somewhere, right? And that way you could store all of these in a few hundred bits at most. I don't expect to have thousands of tiles. Probably more like 10 or 20 bits, right? I would get all of those stored. Other ones, wake up is similar. Although wake up is the kind you shouldn't even be carrying around at all. It's almost like it doesn't matter here. In fact, it's almost like what I want is unequipable or something like that. This is a tile for a different sort of reason. But of course, the possibility remains that I might be making a mistake there by using tiles to create moves, even when I'm not putting them into the data structure. Maybe tiles are more about this fast data structure thing, and they happen to have effects and moves attached to them, but then moves might also come in from another channel, so that moves are a data structure constructed from tiles and other things. That's certainly what's happening here. Tiles have nothing to do with this first choice. So I don't know. I don't know what direction that'll head in the long run. The moves part, at least. Where am I at? I think I was tearing out Chase. Let's see. What do we have here in main? We are initializing everything from the register data. Okay, I think we'll just drop all of this. Like, I'm just doing a deep rewrite of the surface level thing here. All right, later. Thanks for stopping by. All right, I need to take a real quick break before I can continue. So what I'm doing at this point is I'm just going to go and delete out all the stuff from the old state system, because at least that much is definitely wrong. This is probably all wrong too. I mean, we can make that work. We can do a pass over this, but this will work for now. There won't be a moves arena for long. Interesting. Okay. Okay, so some interesting things are going to change here. Figuring out if a tile can be used is no longer going to be about figuring out what state the game is in, and it's going to be about figuring out what state the party is in. Which means we need to know about which entity is trying. Hmm. Screw that. I got a better idea. I guess I just pass him both, actually. So this really is going to be like this. Okay, okay. So we can't get the pointer ahead of time. But we can go... Brain scripts. Okay, all of these are wrong. Okay. This might be a useful function, but I'm gonna just skip to having this right in line right now. Hey, Odin Stream. Nice to see you. Yeah, you're welcome, I suppose. It was a fun project. Well, I'm glad you like it so much. I think I remember just spending months twiddling with the font rendering until it got to the point where I was no longer dissatisfied, so I'm glad it's paying off. It's not a game yet. It's a simulation, although it does work kind of like a game engine in some ways. I suppose it could be on its way to being a certain kind of game engine. Okay. Okay. Okay, I guess this is fine. Okay. Yeah, I'm doing it wrong. There it is. So let me just check this out here. I have a range. I start at the beginning of the range with 2 counters. One of those counters increments every step. Whenever we find one that is less than... Whenever we find a value that is less than our pivot value, we make sure that it goes on the early half of the array by swapping it with J and incrementing J. J stays on the early half because it only increments sometimes. So wherever it's sitting is the next spot that's the front of the back half of the array. Then at the end, the pivot swaps out with that spot putting itself in whatever spot J had. And then we bisect. We do first to J and then one after J to the end until the sizes get small enough that it's over. A little bit hardcore for when there's only 2, but I don't know if I'm going to want this to be generic or not. I might want to expand into more than 2, I could imagine pretty easily. So state array normalize. We don't change the count. We don't change the parties. We just modify all the states and then renormalize. And that's without the parties. All right. I think I'm going to take a lunch break now. Maybe I'll be back in... I might not come back to today. It might be a little late for me by the time I'm done. Yeah, I think we'll just keep... I already streamed today this section for like 3 hours, kind of having a late lunch here. So I think that I'll wrap it up here today. We'll just keep chipping away at this idea for the rest of the week, but this is significant progress. I've got the idea of the new machine structure set up, and the primary sort of building blocks and the main loop. Like, that all feels reasonable. It's building. I don't know if it's even close to... It can't even be very close to functional yet, but that's okay. We'll get there. In the meantime, thanks for coming and hanging out, and I will see y'all around the internet later. Bye.